we're now going to take a look at some of the numerical problems based on distance, rate, and time to get some better idea of the scale of the universe. So here is a question based on the Concorde. It's a luxury plane that cruised at 1,350 miles per hour. I think that's a little under twice the speed of sound. And we want to know how long it would take to fly 93,000 miles. So first, let's get it in hours. So since we know distance is rate times time, we know that that's 93 million as the distance equals 1,350 times the time. And when we solve for this time, this is going to be in hours. And so we can very easily just calculate that out as 93 million divided by 1,350. And that's going to give us 68,889 hours. And then to get this into days, what we'll do is we'll take this number and divide it by the 24 hours in a day. And that's going to give us 2,870 days. And once we divide this by 365.25 days, that's going to give us about 7.9 years. So just under 8 years to get to the sun from the Earth, flying at the speed that the Concorde allows us. Next, we have the Voyager spacecraft moving at about 11 miles a second. So we want to know how many seconds it would take to travel 1 light year. So that's 6 times 10 to the 12th divided by 11. And that's going to give us about 5.5 times 10 to the 11th seconds. Converting this into minutes, we'll divide by 60 to get it in minutes. And that's going to be about 9.1 times 10 to the 9th minutes. And we'll divide this by 60 to get hours. And that's going to give us about 1.52 times 10 to the 8th hours. And then we'll divide this by 24. I'm going to drop one more decimal just to keep it more accurate. Divided by 24. And that's going to be about 6,313,131 days. And then to figure out how many years this is, we'll divide this by 365. .25. And that's giving us about 17,284 years. So one of the fastest spacecraft that we've ever built is going to take us about 17,000 years to travel just 1 light year away. So now we have Mars is about 0.52 AU away from Earth, and we know that if we launch it at a speed of 20,000 miles per hour, we want to know how many months it'll take to get to Mars. So first, let's get 1 AU in miles, and eventually we'll get this into months. So first, here we do need to combine. So you notice Part B is a little simpler, and then Part C is going to require that you do a little bit more creative conversion. And so the distance to Mars is going to be 93 million times 0.52 at our closest approach. And that's going to be 48,360,000 miles. And now let's figure out how many hours it's going to take. So we'll use 48,360,000 equals the rate, which is 20,000, times the time. And that's going to give us 2,418 hours. Now let's get that in months. So 2,418 divided by 24. Let me make sure I have that right. 93, 1, 2, 3. So, 93 million divided by hang on. Yep. Divided by 24 hours in a day is going to give us 100 days. And when we divide that by about, we'll say 30 days in a month. So I should give you that. It's going to be about 3.4 months. So about 3.4 months. All right. Now, let's ask how many months would it take the same spacecraft to travel 1 light year? So, again, 6 times 10 to the 12th miles divided by 20,000 miles is going to be the time in hours. And that's going to be about 300 million hours. Now let's get that in days by dividing by 24. And that's going to give us 12,500,000 days. And then we'll divide this by 30 to get months. And that's going to be 416,667 months. And if I wanted to get this in years, I'd divide it by 12. If I wanted to. We're talking about 34,000 years, but just to kind of get an idea there. Now, using our answer to part C, explain why current technology would make it very difficult for humans to colonize anywhere outside the solar system. The short answer is very simple. It takes too long, meaning greater than 10,000 years, to get to any nearby stars. All right, and now for part E. We want to know how much time does it take light to reach the Earth from the sun? So we have 93 million miles as 1 AU, and we're going to divide that by 186,000. Right, so and that's going to be about 500 seconds. And let's be clear here. We're saying this is the distance and this is the rate. and that's going to be the time. And if we get that in minutes, we'll divide by 60. And that's going to be about 8.3 minutes. All right. Now, here's what we can say. If this is 1 AU as 8.3 minutes, then 30 AU will be 30 times 8.3. And that's going to be 250 minutes. And if we divide this by 60, that's going to give us about 4.2 hours, which I think is roughly 4 hours, 4.2 hours, and I think it's going to give us about 4 hours and 12 minutes.